This is your video resource for completing J.1 and J.3 in the Algebra 2 iXLs. So with J.1, this is all about factoring out a monomial. So it says factor out the greatest common factor. If the greatest common factor is 1, just retype the polynomial. So we want to look at what we have here. You always want to check for numbers and letters as greatest common factors. So I see here I have a 2 and I have a 4 as my coefficients. Well, the greatest number that I can divide 2 and 4 by is 2. So 2 is going to be the first part of my greatest common factor. Now, to have a variable as a greatest common factor, both of your polynomials or both of your terms would have to have that letter present. And you can see here only the first term has an H in it. The second term does not have an H. So there's going to be no letter as part of this greatest common factor, which means 2 is actually the complete greatest common factor. So I have the 2, and then I have to put a parenthesis because we have to write out the entire polynomial, not just the greatest common factor. So when you take that greatest common factor out, you're going to divide your remaining terms by whatever you took out. So I'm dividing by 2. So if I take 2h to the third and I divide by 2, I'm left with h to the third power. If I take a plus 4 and divide it by 2, I'm left with plus 2. Notice I then close the parenthesis on that term. You have to be able to redistribute whatever you took out and get your original polynomial. So here's our next one. Again, it asks us to factor out the greatest common factor, and we do have to rewrite the entire polynomial. So my numbers here, I have a 6 and I have an 8. Well, the greatest number that we can divide 6 and 8 by without getting a fraction or decimal is 2. Both of these terms also have the letter G in them, so I know I'm going to be able to take out G to some power. To figure out what power you're able to take out, you can always take out as much as the lowest exponent that is present. So my first term has a G to the third power. My second term has a G to the first power. The first power is the lower exponent, so that's going to be the one that I take out. Since it is to the first power, I don't have to actually put the to the first power in there. It's understood if it's not present. So then I open my parenthesis. Now I'm going to divide each of the terms on the inside, or the 6g cubed and the 8g, I have to divide them by 2g. 6g cubed divided by 2g, well, I divide the 6 by the 2 and I get a 3. When I divide the g cubed by the g, I'm actually taking 1 away from the exponent. So whatever the exponent is on the outside, that's what you're taking away from the exponent of the term that's going to be on the inside. So that's going to be g to the second power. Because again, if I were to remultiply, g times g squared is g cubed. 8g divided by 2g, well, 8 divided by 2 is 4. G divided by g, well, there was 1 g here, but I took it outside, so there's actually no more g's left. So my second term doesn't actually have a g with it anymore. And this would be your factored form. I'm going to skip a little bit. Try to find something that goes through and does something the way that I want it to. Let's see here. It might just give me the same questions. So this one is 4n. I know I'm moving through this one quickly, but that's because I'm trying to see what happens if we have one that does not have a greatest common factor. So this one is 5c, 4c minus 1. This does illustrate a good point here, because 5c is your greatest common factor, and my second term is a 5c. It can't disappear completely. You do have a 1 as a placeholder. If there were 2 terms to begin with, there still has to be 2 terms inside the parentheses. So I know not one didn't come up like this, but here, if the greatest common factor is 1, just retype the polynomial. That is, you can't take out a number except for one, and they don't both share a variable. You would just retype exactly what the problem was. So let's look at J3 next. And I know you see this J6 highlighted here, but that's actually for a different class. We're not going to be doing that one just yet for this class. So factor quadratics. With this section, you do want to always look for greatest common factor, because most of the terms that are in here, or most of the questions, are going to be factoring when your first term has a coefficient of 1. So this one, I know it looks like there's a 7 here, but you always want to check and see if there's anything you can divide all 3 terms by. And I believe you can divide them all by 7. 98 divided by 7 is 14. 91 divided by 7 is 13. So I can actually take a 7 out of here, and then I'm left with d squared minus 14d, and then plus 13. So because that 7 is my greatest common factor, it does have to appear in my solution. So I'm going to have to put it there in front. Now I'm going to set up my 2 sets of parentheses. I don't have to use the grouping method now because the d squared term has a coefficient of 1. So I am going to have a d and a d. Please make sure you use whatever variable is present in the problem. If you don't use the proper letter, it could mark it wrong. Now I'm looking for factors of positive 13 that add to make negative 14. Since I'm adding to get a negative and multiplying to a positive, they do have to both be negative. And the factors of 13 that add to negative 14 are negative 1 and negative 13. And it doesn't matter what order you put them. You could do d minus 1 and d minus 13, or you could do d minus 13 and d minus 1. It doesn't really matter which way you go with that. Here's another one. With this one, the same thing. There is a greatest common factor. So we can take out a 3. And when we take out the 3, I'm left with w squared plus 8w plus 15. So notice I divided every term by 3. And now I'm looking for factors of 15 that add to make an 8. Well, that's going to be 5 and 3. So that's going to be w plus 5 and w plus 3. And again, it doesn't matter which order you have them in. This one, you don't have to take out a greatest common factor because the first term is already a 1. So you can go straight to your parentheses. I know I'm going to have n in one and an n in the other. Factors of negative 11 that add to make negative 10. I'm multiplying to make a negative, so I do have to have one positive, one negative. So those factors are going to be negative 11 and positive 1. Okay, so that's the idea behind J3. Please go back through, rewatch this if you're not sure. If you need to go back and rewatch the worksheet video or any of the notes videos on this, feel free to do that as well. And reach out to me if you have any questions.